Hello. Today we're going to be doing something called a pedigree. It's a word you might have heard. You might have heard pedigree dog food. This is, by the way, lesson and assignment 29, pedigree work. And you might hear pedigree from dog food or dog breeding, right? Or a horse. Oh, that horse has a great pedigree. Or that dog comes from a line of purebred this. Pedigree is basically like looking at like a family tree showing a trait passed on from generation to generation. That's what a pedigree is. So let's read through this. And now, one thing I'm going to warn you here is you don't have a lot of work to do in this assignment, and I'm going to do some of it with you. Because this, like the last assignment, dihybrid crosses was a bonus, this isn't exactly a bonus, but you need to know the very basic parts of pedigree analysis. And then on the exam or on the test review coming up in a couple lessons, I'm going to do the pedigree section with you on that. You just need to know the basics. Some of the stuff that we have here in this package is a little bit more complicated than we're going to need right now. So keep that in mind, and I'm going to tell you what you need to hand in. You're going to take a picture of some of the work that you've done. And then the rest of it, don't stress. You need to know the very basics. So I'll tell you what you need to know, and then we'll kind of work through it, and you'll get a feel for it. Okay, so geneticists study family trees by observing the occurrence of a trait over several generations. This study helps them understand dominance, sex linkage, and other facts about genes in humans. Knowing the genetic background of a person is often medically useful. Now, look at here. This is a family tree over generations, and you can see the trait is colored in. So this is obviously a family tree studying a certain trait generation after generation. Just an overview, we'll get into it. To predict the probability of an offspring inheriting a particular allele, thus a genetic disorder, is by studying a pedigree. A pedigree is a record of an organism's ancestry. Pedigrees have been used to trace the passing of such genetic disorders as hemophilia in the royal families of Europe, Queen Victoria's line, and more recently, the prevalence of Huntington disease in a tiny fishing village in Venezuela. To draw a pedigree, this is important. Circles are used to represent females, and squares are used to represent males. Okay? Horizontal lines connecting two people indicate marriage, and children are connected by a vertical line drawn from the marriage line. Pretty straightforward. One study involved people with a streak of white hair near the crown. This trait is called the white forelock trait, or we're going to call it piebaldness. Now, what piebaldness means is you've just got a patch of white hair sticking out right here. And it's a trait that's passed on from generation to generation. Let's look at it. Researchers studying people with this trait made a pedigree, which is a record that shows how a trait is inherited over several generations. The pedigree shows that piebaldness is inherited in a pattern typical of a dominant trait controlled by a single dominant recessive gene pair. So, one thing I want you to be comfortable with right now is as we're going to look at other pedigrees later on, you need to generally just be able to look at and say, is this a pedigree that's tracking a dominant trait? Or is this a pedigree that looks more like it's tracking a recessive trait? Now, the trick is basically how often it shows up. If it shows up often, it's probably a dominant trait because anytime it shows up, it takes over. If on our family trees we look and the trait we're looking for only shows up every once in a while, that probably means it's a recessive trait because you need a recessive and a recessive from mother and father to make it show up, which is pretty rare. So if you're seeing a lot of things filled in on a pedigree, it's probably dominant. If you're only seeing a few, it's likely recessive. Let's keep reading. Notice in the second generation that some children have white forelocks and some children have normal hair. This pattern indicates that the parent with the trait is heterozygous. If the parent were homozygous dominant, all the children would have white forelocks. We'll explain that right away once we look at the chart. In addition, the children of heterozygous individuals married to homozygous recessive traits were about half. Don't worry about that. Let's go look at this. So, look at this. We have the dad, and we've given him, the mom, and we've given her a big W, little w, because she has piebaldness. So she has at least one big W. Why didn't we give her a big W, big W? Because if she was big W, every single one of her kids would have a big W. She would have given a big W or a big W. So if we look at her kids, we can kind of backwards trace it and say, well, not every one of her kids is piebald, but she is. She must have one big W and one little. Now, obviously, the dad doesn't have piebaldness. How do we know that? Well, we just look at him. He doesn't have a white patch of hair. So we can say that he's WW, little W's, right? So now we can look at the kids. Oh, this kid had it. This kid had it. So the daughter had it and the daughter had it. But none of the boys of this generation had it. And the people that this woman married and this woman married, they didn't have it either. Yet, there you go. It shows up in the generation again. And there you go. It shows up quite often in that generation. So it's kind of like a way of tracking a trait through family. And sometimes you have to look back a generation or ahead a generation to see whether they are, big W, or big W, little w, right? Because if she was big W, every one of these kids here, not their husbands, obviously there, would have piebaldness. So let's see. Let's take a look at, this is one of the sheets. You don't have to do anything. We're just kind of taking a look at this page to the next one. All right. So look at the pedigree for a dominant trait. Has it? So let's just use the letter D. This person doesn't have it, so they would be little d, right? They don't have it. And this person has it. So we know they have at least one big D. But do they have little? Well, if they had big D, every one of their kids would have it. But they don't, so we know he must be little d. Therefore, we know every one of these kids is big D, little d. Doesn't have it, so it's little d. This kid has it, big D, little d. Little d, little d, little d, little d. The people that they married, this daughter married this man, he doesn't have it, so he's little d. And this person didn't have it, so they're little d. Now look at this couple's children versus this couple's children, okay? Look at, they don't have it at all, and of course, none of their children had it. And this one, well, this dad had it, so some of the kids ended up with it. So it's like tracing a family tree using a little bit of reasoning. It's like a little bit of a puzzle. This is already a little more than you really need to know, but if you're starting to understand, that's cool. Now, there's something down here at the bottom of this page, right? There is something we could say is a carrier. What does that mean? A carrier. Well, let's talk about that, okay? Let's take a look here. Now, what this means here is a pedigree. So for a pedigree for a dominant trait would be, that has to show up. A pedigree, it could be big D, little d, or it could be big D, otherwise. But now, if the trait we're tracking is recessive, that means it needs to be little d to show up. So anybody that has it in a recessive family pedigree trait, we know automatically that they are going to be, let's see here, they are going to be, so anybody that has it, little d. And this person has it, so they're going to be little d. So we can fill in everybody that has it, first of all. Little d. Now, you don't need to do this. This is just going through it right now because the next sheet's going to be the first thing we work on. But let's take a look. So if this person had a little d, and so did this person, sister and a brother of this generation, well, they got one little d from one of their parents, and they got another little d from their other, which means mom and dad of this generation both must have a little d. Now, what's the problem here? If they had little d, what would these two parents have? They would have the trait as well, but they don't because they're not colored in. So we know they must have one big D and one little d. Now, in recessives, if you are carrying that little letter that could show up, if we're tracing it, if you get little d, that means if you have one little d, you are what we call a carrier because you have that gene that you could pass on, but it's normally going to get taken over by a big D, so it'll never show up in your kids. It's very rare. So we can look here. We know that this parent is heterozygous there. This person obviously didn't have it, so they're going to be big D, little d, or big D, we don't know, right? This person didn't have it. But look at, half of their kids did. They're carriers. Anybody that's a carrier now, you can fill in big D, little d. Just something to think about. So in a recessive pedigree, there's something called carriers. Don't worry about that yet. Let's take a look. All right. Now this is color blindness. Color blindness is a sex-linked, which is what our next lesson is on, sex-linked traits. And this is pretty cool after on the next lesson. But let's look at a sex-linked recessive trait. Okay, so it's sex-linked and recessive. So we'll use C. So we'll use big C, means you're not colorblind. Little c, not colorblind. So not colorblind, not colorblind. But little c means you are colorblind. Okay, so first of all, we know that this person is colorblind because they told us. So we know that they're little c, little c. And we know these people are little c, little c, little c, little c. Now look at this. Every one of those is a carrier. So none of their kids are colorblind, because if one of their parents had it was a carrier, you'd have a couple kids show up here with colorblind. So we've got to know that this mom is big C, big C. Same with these parents. None of their kids ever show any color blindness or carriers, so we can put big C, big C, big C, big C. Now we know that this kid and this carrier, big C, little c, have kids, and of course a carrier. And look at this, color blindness shows up there. How does that happen? We'll have to see. Don't get too stressed out about this right now. I'm going to flip on to the next page. I'm going to kind of leave you hanging on that. This is the first sheet you're going to have to do. And now this sheet here with the mouse, this sheet is much easier than what we've just done. So I want you to do this quickly on your own, okay? So this is grandparents, parents, and the children, right? How many of the grandparents have extra long tails? You can read what this says, right? So let's see. A pedigree traces connected marriage, blah, 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 blah. The pedigree below traces the occurrence of extra long tails. How many of the grandparents have extra long tails? 2 tails. Do more males or females have? Well, that's up for you to decide looking at circles versus squares. Now, here's a great one. There are 3 female and 4 male mice in a litter. Only 2 of the females and 1 of the males have pink noses. The father has a pink nose, but their mother does not. The father has 2 sisters with pink noses. The mother has 3 brothers, but none of them have pink noses. The father's father has a black nose, but both the mothers have a pink nose. Both of the mother's parents have gray noses. How would you draw that out? So you have to actually make a pedigree there. Okay, let's do this one together. There are 3 female and 4 male mice in a litter. Okay, I can do that. 3 female, 2, 3 females, and 4 males. Great. Okay, now they're all in a litter. So they all are brother and sister. Okay, good. Only 2 of the females and 1 of the males have pink noses. Okay, so I'll circle them in. Pink nose, pink nose, pink nose. Okay. Their father has a pink nose, but their mother does not. So we draw their generation. Their mother doesn't have a pink nose, but their father, he does. Okay. The father has 2 sisters with pink noses. So his sisters, they both have pink noses. The mother has 3 brothers, but none have pink noses. Okay, so she's got 3 brothers, but they all don't have pink noses. All right. The father's father, okay, has a black nose, and the father's mother has a pink nose. Okay. And both of the mother's parents have gray noses, so they don't have it. Okay. How many mice in the family have pink noses? 1, 2, 3, 4, 5, 6, 7. Yep. How many male mice are in the family? You can count up the squares. How many pink-nosed female mice are in this family? You can do that too. So if you could do something like this page right here. Oops, sorry. If you could do something like this page, you're in pretty good shape. I think this might have just reloaded us to the beginning. Sorry about that. But if you can do something, let's look down here then. If you can do something like this, you're in good shape. Now, the other thing here that we've included are a couple extra sheets here. How organisms get their traits. And these questions here. And I believe these are a little more than you need to know right now. But if you want to look at those sheets and try pedigrees out, you can. So I'm going to put the answers up for those sheets right now. You don't need to submit those. The only thing you have to submit to me for this one is this mouse page. One page, easy section. But I am going to give you the answers right now for the other pages if you're inclined. The biggest things to know right now is that use squares for men, circles for females. Lines show they're married. Children go up a branch. Another thing to know is if you have it, you fill it in. If you are a carrier, you half fill it in. Now remember, carriers are only in recessive trait pedigrees. If we're doing a dominant trait pedigree, you're going to have lots colored in, and if you have any dominance in any of your family members, it shows up in them and you fill it in. If we're doing a recessive trait pedigree, you might not have the trait, but you could be a carrier. That's why you would half fill it in. And don't worry, because there's the best question for this is on the test review coming up in a couple lessons, and we're going to do that one together, so you won't be stressed out about it. You're going to know the basics of pedigree, and that's all you need to know. So now, if you decide to work ahead and do the other pedigree questions, I'm just going to give you these answers so you can look at them. So you can pause it right now and try what you like, but here are the answers for the other sections here, okay? So I'm just going to slowly scroll through them for you. You can pause them as you need. And here is the other page of answers. Okay, so pause them if you need. So I hope this was kind of fun. If you could do the basic mouse page, you're okay. And like I said, the hardest question, the best question we're going to do is going to be on the test review. And I'm going to do it with you, so you should be prepared. This isn't quite a bonus activity, but you should know what a pedigree is, that it's a family tree tracing. So take care. We'll be looking at sex-linked genes next.